Welcome to this MooreChat, and I appreciate you pulling in early. I know it's pretty early, especially on the West Coast, and I plan to present for maybe around 7 to 10 minutes. Then we can have a discussion. So this is a presentation about what project is still undergoing in Pune, and the broad outline of the presentation is that we'll see the problem statement, then what type of challenges are there in this project and what solution approach and solutions we provided, and finally learning on the in this project. This is a project located in Pune, and our structure group is designing a full building. This is called Gagan Arbor Court, and originally when it was planned, I think about 2 or 2.5 years back, it was 15-story structure, but structure group put two additional floors as a margin at that time. So that what we have initial design, let's call it version V0. So that design was for 17 floors. And sometime around 1 year back, early January last year, there was a revision in rules in the Pune municipality area, and the benefit was received by to this particular building, and they were able to add three additional floors on top of the building. So let's call this a version V1. So we started working closely with the structures group and um, design the design the retrofitting or strengthening of the construction part which was there. And we submitted our final drawing sometime June or July last year. And while they were planning to do the retrofit work, they got additional FRA, and this resulted in one more addition of two more floors. So talking about the structural system of the original plan, so this is the periphery of the building, and here is the rendering, architectural rendering of the building. So this part is the front of the building, which is on the right side of the plan, and gray area is typical floor level till the ground level, and above that I have highlighted this particular rectangle, which is the tower portion, which goes till 17th floor or 15th floor as per original plan. And the structural system of the building is such that central columns are gravity columns, and peripheral columns and beams and these L-shaped shear walls, they form the lateral racing system of the entire building. So when additional floors were added in the recent modification, which we are working on since about 2 months now, they not only had a vertical expansion of two floors, but also additional expansion over here, which is from ground floor or yeah, from ground floor till 22nd floor. So for that, structure group has come up with this two additional L shaped over here, two additional columns along the periphery, and two intermediate columns. And the overall dimension of the building is about 360 by 104 feet, and with the column spacing of a grid of roughly of the order of 26 to 27 feet, uh, square kind of thing, rectangle about 27 by 26 feet. That's a rough sketch of entire building. When we started doing it last year, the main challenges was this is the construction photograph at the beginning of the last year, when part of the basement 3 was still under construction. They were not even started the foundation. Part of the basement 2 was constructed, and part of the basement 1 and ground floor were constructed. So we started thinking about what could be the best retrofitting solution or strengthening solution for this building, which the portion which were constructed. So including majority of the footing, few columns and beam at this particular level. So since the building was still under construction, and there was no restriction kind of thing or evacuation kind of thing required. So we decided to go with the concrete jacketing itself, because one thing is the material was compatible, everything is in concrete, so we can just add more concrete to it. And FRP, of course, this doesn't 2-hour fire rating, which was required for the FRP, that we will not get in this case, since we need to strengthen so many columns. And of course, steel jacketing was another thing which was problematic from the execution point of view, as well as skill labor point of view here in India. And another major challenges was from the architectural limitations, that column to column distance was in such a manner that they had a few clearance or minimum distance was a must. So we worked closely with them and tried to find out which columns were appreciable, means thickening of columns was appreciable, what by how much amount, maybe it is 4 inch or 6 inch, just 2 inch restriction, and based on that we designed the retrofit. So the approach that we took, since the entire building was designed by Walter P. Moore, the analytical model we had readily available from our SCSG group. What are the global design forces in terms of earthquake or wind or other gravity loads? They were readily available to us. They did the deflection calculation and global check. So we didn't cross check or cross verify any of them. We just use their model as it is. And where we focused on is the strengthening design. So whichever the columns were already built at that point of time. So for vertical elements, for columns and shear walls, we used ETAP section designer, as you can see here. So this was the original column, and we just extended it towards the left, right, or whichever was the permissible. So, for instance, this column was eccentric in its final execution, because this side ramp was there. So it was not possible to extend the column on this side. So we model exactly what we wanted with the position of rebars, and then put this section into the ETAPs, and we could get the design to capacity ratio directly from the ETAPs. And then horizontal elements like beams, we did the spreadsheet comparison, that what was the provided and what is the new requirement from the updated construction. And then for the footing, it was a combination of safe model as well as a spreadsheet checking. So that was our overall approach. This we could provide solution in terms of column strengthening. As you can see, the extra reinforcement which were there, they were they were added to the existing column using some U dowels, and size of dowel as well as spacing of dowel around the vertical line. We used ACI code to get those values, since there are no equivalent code available in India. Widening part, or how much strengthening, how much jacketing should be done, they were provided as per Indian code, as well as what our ETAPS model suggested. And same thing was required for a footing part. In the footing, at some locations, um, we had need to widen the footing. So this you can see plan of the footing, where we had to widen it a bit because of addition of 2 floors. And at some places we also need to thicken the footing, because at few places punching shear was exceeding. So uh, there was no other option than to uh, provide more thickness to the footing, uh, and bring the punching shear within the acceptable limit. So this was a partly it was executed, and then the recent upgradation come, and we are still working on that. We have issued the column strengthening drawing and shear wall strengthening drawing, and we are in a process of giving designing the foundation, as well as checking the beams and horizontal elements. So this was there are some photographs from the last year's execution which they did. So for example, this is one particular column where the additional rebars were doweled into the column, and they just before pouring the additional concrete, they just get rid of slab in the vicinity, so that flowability of the column is maintained, and they don't have any problem in putting additional rebars. So they used this as one of the solutions. At some other place, this was the ground floor at that time. Probably this is sometime during August or September last year. So when where the flooring was means concrete was just to yet to be poured, they just drill holes in the shuttering and then provided the reinforcement in the vertical direction, and then they poured it. And the bottom side of the same column looks something like this, uh, where the bar from the upper side was still hanging, and during the strengthening, they will chip this column off and then provide U dowels and get the overall strengthening done as per our provided schedule. So it was a exciting project for us to work on it, because we are first time we are still in the initial stages of diagnostic practices in India, and overall as a diagnostic service, India is in a nascent state, and people are still learning about the such kind of solutions, strengthening solutions. So probably the most important lesson for us with the coordination. So coordination amongst our team, diagnostic team, and then as a structures team. So at one point of time, we were using different models and structures and different models uh, in diagnostics. So that we realized, and then uh, coordinated the effort and put started using only one model, and whatever modification they do, they supply to us, and whatever modification we did for especially for the ETAPS section designer, widening the columns or putting additional rebars. So once we update, then only they use it. And then one more important learning was in terms of understanding Indian standards. So um, there are Indian standards available, but the type of information available is scattered through different standards, I would say. And understanding them and providing it into the workable solution, so that on-site contractor can seamlessly use it. That was the one of the important learning. And we found out that section designer is a great tool. In the very beginning of the design of strengthening, we decided to use section designers for all the columns which we are strengthening. It took a lot of time to build or place those additional rebars exactly at the same time. Not only the new rebars which we were proposing, but additional rebars as well. But once it was ready, we found it very handy. And now that when they asked us to do more floors on the final version of the building, or version 2 of the building, we were very quickly able to use those section designer to find out whether the sections are still capable to take additional floor loads, or we need to add some more rebars or need to widen the columns. There's one more additional information that I want to share with you all, that during my discussion with Hakim and Clint earlier and Vogue now, this is a foundation system that probably is not common in the US. So I thought to just add this thing here. So here what you are looking is a section of footing, and soil was good enough so that isolated footings were required. But since this was a foundation, this was a basement tree, and which was still used for the car parking and DG sets and other things. So what we do here is, instead of putting slab at the top, which is probably, I understand, common practice in US, but we provide it at the bottom. So this is called, as you can see, the stitch slab. So it has all the reinforcement calculation as per to reduce the vertical load, as vertical pour water load, which is during heavy rain season. And probably a benefit I can think of, that you can have a uniform waterproofing below this, and as well as when you level this uh, till the top of foundation, that acts as a counterweight and gives benefit to resist the vertical water pressure. I thought to share this because probably this is a new thing over there. With that, I come to end of the presentation, and we are open for questions.
Ashish, I have a question. Well, first of all, this is Enrique and in Charlotte. Great, great project. Very interesting. Congratulations.
Thank you.
Um, my question is, did you also have to retrofit the shear walls?
No, shear walls were on the periphery only, and there were not actively participating in earthquake load. So this all gray area that you see is a podium level, and it stops at, I think, ground floor or at max one floor above that. So it was not taking active participation in transferring the lateral load system.
I would have imagined that adding 3 floors and the shear walls taking or having the most stiffness, they would take a lot of additional load. So I would have imagined those would have needed retrofit as well. Okay, thank you very much.
So maybe if there's no question, I can share some more information about it. Uh, the in the recent the version, or say on 22nd floor, so what they did additionally, in addition to having extra floor, they also introduced stack parking of the cars at the I think car parking level was just above the ground level. But since the construction had not reached that till that level, so we had structural group took care of design of that particular level, and only the additional force due to that stack parking and extra car load was reached to us, and then we use the those forces in column strengthening below.
Ashish, I have another question since.
Yeah.
So I think you mentioned that it was in an iterative process between you like finding the new cross section of your columns, and then did you supply those dimensions back to SESG so that they can update their model and the deflections and drifts?
Yes. Yeah. So the way it worked, we started working on the model given by them. We added modified the cross sections, added those to model, and then supplied the same ETFs model back to them, and then they checked deflections and other global check, whatever they thought appropriate, and then they again supplied back to us, because while we were strengthening the elements which were already constructed, they were also doing the same thing, but their elements were not still constructed. So for example, if some column above the ground floor had say 700 by 1000 dimension, but because of additional thing it needed to increase from 700 to 1000 to 900 to 1200. So they were doing that part, and
Okay.
then of course it was at few columns, I can remember that we didn't want to there was no requirement for us to widen it below the ground floor level, but because of some deflection or other criteria they needed to widen it at the upper level. So we had to ensure that whatever the maximum size their column is, it's transferred till the foundation level. Even if we didn't need it, we provided the widening in the lower level which was constructed.
I have one question, Ashish. Do you do any treatment for the to assure the adhesion between the old concrete and the new concrete?
We just asked them to chip off the existing column faces or shear wall faces up to a half inch, and then pour the new concrete. But there was as such no treatment from chemical adhesive or some other point of other solution. It was relied based on the frictional thing between the old concrete and new concrete.
Ashish, I have a question. This is Mazi from Canada. Well, my first question is about the tolerances of the existing structure where you were reinforcing. How did you model that in your ETAPS model? And the other question is that when you were reinforcing or adding, changing the profile of the existing structures or reinforcing them or adding sections to them, how did you establish the quality and performance of the existing materials used on site? In terms of quality and performance, the quality placed on site, how did you come up with that, the physical properties and performance so that you can basically create a baseline for reinforcing the existing shear walls or columns?
By quality, you mean the grade of concrete and
Yeah, and the
okay.
steel. Yeah, the grade
And
of steel, the
yeah,
performance of the entire, I guess, load carrying components
yeah.
of the building. Yeah, thank
Yeah,
you.
so the material properties, whatever concrete has come on the site, we instructed to follow the same quality control that they are following for the other parts of the building, means which is the fresh construction. So the number of cubes that they check or number of cores that they take, it's the same pattern which they cast for the which they use for the new construction. So whenever they use the concrete for strengthening or jacketing purposes, so we ask them to take the same number of cubes per truck or similar quality check. And same thing was for steel also. So steel is also since the building is still under construction, the same material supplier provided that steel as well, and same tests were applied on those steel bars also.
What about
Uh,
erection tolerances, like out of plumbness and stuff like that? Obviously, there are some. How did that come into play when you were sizing new sections?
yeah, erection tolerance. I think since the building was already constructed, so they had to maintain the verticality only from floor to floor, and the column or the new additional bars we had asked them to drill throughout the slab, or in one case, as you see here, concrete or slab in the vicinity of the column, and that helped to maintain the verticality of the due bars, as well as the verticality of the shuttering and entire cross section of the column as a whole. If you have any suggestions also, then please share that based on your experience on in US, if there is something you think we should take care during the execution or drawing or design, I would appreciate it.
Uh, One thing that I'm not sure how it works. Usually, the class of concrete poured in columns, maybe the interior columns may be different than exterior columns, and then what we call it as a puddle concrete, the concrete that is poured on the slab in the vicinity of the columns, it's different. It has a different F prime C. So because this is an existing poured, I don't know how would that be affected by increasing the size of the column because the section is increasing and the concrete adjacent to the column may not be the same. I don't know if you,
Yes.
yeah.
Yeah, so for that, what Indian code requires is that compressive strength of the new concrete should be at least 5 megapascal more than existing concrete. So these columns which are designed for M40 grade, so that is 40 megapascal, that's I guess around 5800 psi. So we provided here M45 grade concrete. We asked to pour 5 megapixel higher strength as per Indian standard.
What about the floor slab?
Floor slab, since there was no additional load on the floor slab, we checked it, but strengthening was not required on them.
Is it the same grade of concrete poured on the slab and the columns, or are they different grades?
No, there were different grades. If 40 grade concrete was there for columns, probably it was 30 grade for slab.
I was going to ask, how many man hours did you put into this
Yeah,
project?
so for this project, which we completed last year, around 200 man hours of G's and myself for entire design check and then execute, including drafting requirements.
Hey, Ashish, this is Jacob. First of all, interesting project. I probably want to ask you a question that you already described earlier because I'm, as usual, trying to do too many things at once. But whenever we do these column strengthening projects, there's always a great question that comes up about how much load is actually being supported by the enlargement, because we're typically not unloading the structure, at least in a lot of the stuff that I'm involved with. This one looks quite different in that they're taking out the slabs. I'm kind of curious in your analysis on these columns, how did you did you do anything to partition that load between the concrete that remains versus what gets added on? Are you, I'm just kind of curious what your underlying assumptions were there and how you handled load transfer between the two, the original and the new concrete.
Yeah. Okay. Interesting question. So, what we had one part is whether there will be effective load transfer between new concrete and old concrete. Because so I think we thought that it will be because the building is still under construction and they had gone just
Yeah.
1 or 2 floors and more than 15, 17 floors are yet to come. So about that, we didn't have a doubt that once we have a wider column, that effective transfer will eventually happen.
Yeah.
And to how will it transfer, or how will you keep those two new and older concrete together? We used U-shaped dowels, and we used ACI guidelines, which says yeah. So the area of um, area of new concrete and area divided by area of or rather ratio of new concrete versus old concrete. So in that manner, that will be the load transfer between the new between the two columns. And that we assume that since it is going to load transfer to the through the shear, so these number of dowels should be sufficient to take care of that load transfer. So that's how this area of dowel and number of dowels were decided, including their vertical spacing.
And then this is always a topic of debate. And I'll just, my perspective, I have been asked to strengthen columns in buildings that are completely built. And then they find out they have low strength concrete. So I'm just kind of curious if you had any thoughts on shear friction as you're, checking the provision of 318 for shear friction when you're trying to share load between those two, two pieces of concrete essentially.
Yeah, so here we assume that entire friction, entire force will transfer through the dowels. We ignore kind of friction between the concretes, and the entire force between new and old will transfer through all those rebars. So that was our underlying assumption.
Okay, all right. I got to run, Ashish. Thanks for the presentation, and
Thanks.
it's an interesting one. So we'll send you all of our column strengthening stuff that we got here in Dallas. So.
All right. Well, I think if there are no other questions, we can wrap up. Ashish, does that sound good?
Thank you,
Have
Ashish.
a
Very
great
good.
day.
Thank you.
Thanks.
Thanks, Atish. Great presentation.